Hi, that's Lars again. Welcome to my second talk today. And this time we want to talk about automotive network security. And I want to talk about some misunderstandings, some myths you might find, and trying to debunk them. The talk is structured as follows. We will have a short introduction, and we will look at 6 selected myths, and want to look into them, try to understand them, and see if you can debunk them. And then we end the talk. So as introduction, automotive and security, or security and automotive, are 2 different ways to look at the same problem. If I'm at automotive and looking at security, so security was at the last years was just starting to become interesting. Many years ago, only stealing a car would be an interesting security use case. But these days, we have more and more use cases since the car is getting connected to the internet. If you look at the security guys and their perspective on automotive, it was quite different. The car itself is an interesting target for a security attack, so for security research, cars are really interesting. However, the product, while being interesting, is not that known to the security world, or was not known to the security world a few years ago. There are examples of papers you can see online where security researchers tried to manipulate data on a canvas and they failed, and they determined that there was some security on it. But the only thing that was on that canvas was a CRC that they didn't know about and could not calculate, since they didn't understand how the CAN communication works. In this talk, we want to try to narrow the gap of those 2 perspectives a bit and discuss some misunderstandings on both sides. Let's start with myth number 1. Only application-to-application security solutions are secure, and that myth probably comes from the understanding of the automotive guys of what end-to-end means. What does end-to-end security really mean? It's quite difficult to say in the automotive world because people try to think first about safety, and end-to-end safety tries to minimize the stack that is not covered by the safety solution. So if you think about safety, end-to-end safety does start in the application, or at least very close to the application, and ends in the application. So application to application as a safety concept is really common in the thinking. When you look now for security, that's not what end-to-end security really means in the IT world. There we often discuss more that the security starts in a system and ends in a system, but it's not necessarily the application. So what are the solutions that would give you such a security, and does that make sense? So let's look at the first solution we can use in automotive security, automotive network security, and it's called Secure Onboard Communication Standardized by AUTOSAR. That's basically an extension that is built into the classic AUTOSAR stack. And being implemented in a stack, that surely is not application-to-application security. What we have here is what I would call an end-to-end security solution, since it's from system to system, but it's surely not application-to-application. So if only application-to-application security would be secure, SecOC surely is not a solution you can use. The next solution you can use or look at is IPsec. IP security, or IPsec for short, is an IETF protocol which comes from the internet world. Basically, it's used in many VPN solutions, or solutions when you, for instance, in these times connect with the VPN back to your office. IPsec itself has different protocols in it. One is AH that can do only authentication, one is ESP that can do authentication and encryption, and as well 2 modes are supported, one is tunnel mode and one is transport mode. But with those protocols and those modes, can I make IPsec application-to-application secure? And the answer is no again, because it's implemented in a TCP/IP stack. So no matter what mode you use, what protocol, while IPsec I would consider to be end-to-end secure, or provide end-to-end security, it's surely not between the applications after all. Okay, the next solution we want to look at is TLS, the protocol formerly known as SSL. TLS can be linked to an application in the IT world, so it's a good candidate for being an end-to-end security solution that reaches from application to application. However, if you look into the AUTOSAR specification for the classic platform, that's not true, because it's implemented in a stack. Only when you look at a socket-based operating system like Linux, you have the opportunity to link TLS to the application so that the security is in the application. However, if you need some acceleration, which you typically do in an automotive system for cryptography or the TLS protocol itself, then of course you use a shared resource of the operating system, of the system overall. And that basically means that you're not application to application again, you're again end to end in my opinion, but it's not really as in the safety world. So what do we learn here? Basically my understanding is that end-to-end security is often said, and the end-to-end safety, like application to application safety, is meant by saying that. And that's something that automotive engineers often do wrong. You cannot achieve that kind of model for security with solutions like SecOC, IPsec or TLS, and not with MacSec either. You cannot achieve it if you have shared resources like crypto acceleration or like protocol acceleration. So at the end, what only makes sense is that end-to-end has the same wording or meaning as in the IT industry, meaning that end-to-end means you don't have an intermediate node that can work on that data. It doesn't have to do anything with your application, it's just the way it is. But maybe the old discussion about the application security is more about ACLs and not about the security solution itself. And we will look into that in the next slides. So for the time being, make sure that your end-to-end security definition makes sense. So myth number 2, and I've already spoiled it. It's about the access control and where you place that in regard to your security solution. Do you put it in the application? Do you make the security end there to do it? So the myth is access control only works if the security ends in the application or ends close to the access control. And the fundamental idea here is that like in the internet, everything can be spoofed. Your IP addresses can be spoofed, your port numbers can be spoofed, your data can be spoofed. So only if those are protected by your security solution, you can really trust in them. And on the internet, that's probably true, right? So if you look at your browser, it makes a lot of sense to put the TLS implementation into your browser. And then you can do all the checks in there. You don't have to trust the operating system. You know what you do. And in the browser, it's really important that the user can control what happens if certificates are wrong, for instance, or are expired. So you have some user influence in those as well. So placing that control and the security solution in the application makes sense for the internet. But is that true for in-vehicle networks? So I would argue that the situation in in-vehicle networks is quite different. Inside the vehicle, the OEM controls all the parts in a system and a setup. So there's a lot of possibilities. You can design and engineer your network in a way that really helps to achieve the security you need. It's possible to segment or separate the network by use of VLANs, for instance. So you have separate virtual VLANs in the system and you can base your security on those. And as of course, you are even in the situation that you can ensure that IP spoofing and port address spoofing is not possible by doing the right filtering, doing the right design. As an example, if you use even hop-by-hop based MACsec, and I would highly recommend that you consider that, and combine that hop-by-hop MACsec with a strong filtering on Ethernet switches, you can enforce the VLANs, you can enforce the IP addresses, and you can do efficient and effective firewalling on the hosts, even that the security didn't reach to them, because your setup makes spoofing IP addresses and port numbers impossible. That means that I can then implement the ACLs all over the system, every place I want them, because I can trust those information that I can identify an issue by the IP address. So what is the takeaway here? Access control can be distributed if your holistic network security design works. So let's go for the next myth. Every protocol needs security built in. Over the years, I've often heard that every protocol needs to have a security part built in, or maybe you have to have ACLs in every protocol or a security solution in every protocol. Is that true? Do you need it for all the protocols? On the right side of the slide, I've shown you an example stack, and you can see there's like ARP or diagnostics over IP, There are different TCP/IP protocols or parts of the TCP/IP stack, and all of those need security. I'm not sure about that. So let's look at them into detail. If you look for the diagnostics over IP, of course, that reaches out of the car, their security makes sense. You might want to use TLS below it, or maybe use security inside it, or the combination of both. But do you need to protect all the messages inside your network? For instance, the UDP/NM network management messages with security, and doing that by build the security into the protocol? I don't think that is true. But let's take another view on this problem. So let's start with the attacker model. What kind of attackers would be there that can manipulate data of that? So first of all, the external attacker. The external attacker can modify links and maybe go directly to the cable, change the cable, plug something between. That's what we call an external attacker here. So we can replace ECUs, we can change cables. So every message between ECUs basically could be modified. But if you protect them, and MACsec, for instance, allows you to protect all of those messages, you cannot modify those messages anymore. So it doesn't depend on the protocol itself. You can just protect everything against that external attacker. So no, for the external attacker, it really doesn't make a big difference here. What about internal attackers? If they're an external attacker, there should be an internal attacker as well, right? So internal attackers, what we understand here is that an ECU is already compromised. Let's imagine you have a head unit, and over the air, over the internet, over an attached USB or Bluetooth device, that head unit was attacked, successfully attacked. So it's compromised, and some attacker controls on the head unit. So just protecting the messages against changes does not help, right? You need to make sure that you have something to stop the attacker here. And basically, while the head unit can do different things, it might not be allowed to do everything. So by using an ACL, you can stop the attacks. If you think about that, a firewall, an IP or TCP/IP firewall, is basically something like an ACL as well. And in that case, you don't put that into IP or don't put that in TCP, but you put it below both of them in order to protect them with it. So you can build the ACL, but you don't have to place it in the protocol. However, what's important, you need to be able to filter based on those things. IP addresses, port numbers, or maybe your someip service ID or method ID. So make sure that you have access control and filtering in place. Myth number 4. IDS and IPS are most important. So the intrusion detection system, IDS, and the intrusion prevention system are really important security features in the IT world. But are they the most important features you can put into your car? So detecting intrusions is quite valuable. You can understand what the attackers are doing, and if you understand it early, you might be able to already change something on the cars in order to fight the large-scale attack before it happens. So the attacker might have tried out the attack first, and in your intrusion detection system, you have seen that attack, and you could counter that attack before it happens. If you look today in the market, many people are offering intrusion detection systems or intrusion prevention systems. So my feeling right now is, with the many people offering those systems, that those features only seem to be really important because there's a lot of marketing budget behind it. People are talking about those features or telling you that you need it, and the technical depth isn't that great. So when you want to put that in your car, what do you need actually? You need a way to transport events between your car back to your backend or infrastructure, so you can collect those events. And then in addition, you need some sensors in your car, some pieces of software that collect some events, which you then transport to the backend. With those events, you can then do analysis and understand attacks better or find those attacks. So that's quite useful, but you don't need to buy a finished system and put it in right now. If you start just with the path to transport the events to your backend, and then start by adding events which are then transported over the added way. Intrusion prevention systems, on the other hand, they try to actively stop attacks. So if they think that there's an attack going on, they try to shut off things in order to make that attack not viable anymore. If you think about autonomous driving cars, are you really happy that an IPS now starts actively stopping attacks? That sounds kind of dangerous to my ears. So you might not want to run that path. Make sure that you have more in your toolbox than the IDS. So the IDS is not the only tool in the toolbox, and create a strategy for it. And you don't have to edit at once, right? You have time and edit step by step down the path. Myth number 5, security does not allow testing. As you might expect, we are strong in testing in the company, and we do a lot of security consulting for different OEMs. So we are confronted often with the problem that people think that when you put security, especially network security protocols in your car, that you cannot test anymore. So they say like, I need to test first and then do the security afterwards. And we all know that doesn't work, right? You can never meet that timeline. So the idea comes from the understanding that security encrypts all data, right? I cannot look into the data anymore because it's encrypted. So I cannot do any analysis later on what went wrong if I find a bug. So the good message is that's not true. If you look at Secure Onboard Communication SecOC, it was designed with the authentication only use case in mind first. I mean, you can do input encryption in that, in theory, but why would you, right? It works authentication only. If you look at other solutions like IPsec, TLS, and MACsec, they all support an authentication only mode. So you can use authentication only there as well. In order to prove that, we have a small, tiny screenshot down here on the slide, which shows that we're using MACsec, have turned on MACsec, and you can still see the ARP packet protected by MACsec. Actually, if you want that patch, we already supplied that to the Wireshark project, and hopefully it will be part of the next release. That's probably 3.4. So if we can do that now, that we can look into the data, then what else is a problem for the testing? So the next thing you might run into is like, but if you authenticate all the packets, what happens if for a test I want to manipulate some messages, right? I want to change them. I want to simulate one side of one ECU maybe. So that is possible as well. What you can do here is two main strategies which work out. The first one is either you create a secure process to turn security on and off in your ECU. So you can do some of the tests with security turned off, and then do other tests, for instance, in the car with security turned on. Or maybe even better, you had a secure process to install the keys or certificates, whatever you have for the security, into your test system and ECUs at the same time. So the test system basically looks like an ECU now, and you can do everything the ECU could do, and the security does not stand in your way on changing messages. As a bonus, the security engineers usually really are happy if you do a lot of testing. They really are basically focusing on the same direction as you are. More testing means less bugs means better security. So security requires you to test a lot. So the security guys are really helpful if you want to do more testing, and they don't want to stand in the way of that. So what do we take away here? Network security allows testing. Know your tool chains and design your processes in order to allow testing when network security is in place. Myth number 6, security does not allow agile development. For security, you typically go ahead and analyze the requirements in order to identify what security needs you have. And then you put those mechanisms into the system. But that doesn't really work well if you want to be fast. Because the problem you're having now is that for every new feature, you do this analysis and figure out that you have to add some security. So if you want to add a feature very late in the development, shortly before SOP, then of course you don't have enough time to do the analysis and add all the security. Even worse, if you have the possibility to add features over the air later, you cannot really change the security that easily anymore. So if you want to be agile, if you want to be fast, you have to rethink your strategy here. What is the solution? The solution is turn things around. Don't think about what you want to put in and then analyze for the security, but build your generic security in and then put the things on top. So you always design with generic security built in. That means, for instance, you protect all messages on a communication. You do ACLs for all your protocols needed. Then, when you introduce a new feature, you can check if that existing security framework is good enough, and you can use that. The chances are that you have the right security already in place. So if you do this analysis and you can confirm that security is okay, then you can already bring the new feature. You're happy, you're very agile, you're fast. If you have to add a little security, then of course you have to add some security, but chances are it's not that much you have to add. Most important, stop discussions like, is the security mechanism really needed? Who wants to pay for that? No, the customer doesn't need that. Because those always lead for you to minimizing the security and running into problems later. Understand that your security is the platform that enables features in the future, and build it like that. Put it in there, be proud that you have a broad security implementation that can protect features you haven't thought about yet. So, takeaway, understand that security is an enabler for the future and don't minimize it. Let's come to the conclusion of this talk. Security in automotive is a little new. Right? We're only doing this for a couple of years, and there are many things that are unknown and therefore might be misunderstood. For many IT security professionals and experts, the automotive world seems to be a little new as well. Right? I have told you that some did not even understand that a CRC is not a means of security but safety. So in this talk we have looked at some of the common myths of automotive security, and maybe we have bridged the gap a bit between those two worlds. So what have we looked at? We have looked at the myth that only security between application is really secure, and we have seen that's not true. We have seen that SecOC, for instance, cannot do that. We have seen that IPsec and TLS cannot do that. That's not the way it is. The second myth was access control needs to be inside every application or every application protocol. We have seen that that's not true either. You can do the access control, for instance, if you look at firewalling, you can do this below the protocols. You can do it in different spaces, and you have to design your overall system in order to cope with that. Myth number 3, every protocol needs security. That's not true either. We have seen that you have the possibility to use one security protocol to protect your protocols, but you don't necessarily need to put security into every protocol. It's really important that you figure out how to protect all the possible intrusion vectors for the attacker, but don't think about putting a security in every single piece of every single protocol. Myth number 4, IDS and IPS are the most important security mechanisms you want to put in your car. And here we have seen that there is not that much magic behind those concepts, and you can add them over time to your car if you have the right strategy. There are probably other mechanisms like software signatures or network security that are more important than the IDS part. Keep that in mind. Myth number 4, security does not allow testing. And we have also shown that that's not true. Security can allow testing because you can do authentication only for the network security, and you can read all the messages, or you can find a process that you can even manipulate messages for testing. You have to plan for that, you have to design that in. But if you do it the right way, security and testing work together fine. And the last myth, number 6, with security, agile development is not possible anymore. And what we have seen is that if you have a very traditional security process in which you build something, then do the analysis and then add the security needed, you probably are right. You're not very agile anymore. However, we have pointed out that if you build your security as a platform, as an enabler for your future features, then the agility comes back and you can be agile again. That's the recommended way on working. Don't minimize your security, understand it as an enabler. Overall, it's really important that the security and the automotive engineers come closer together. If you already understand both worlds, that's perfect, but unfortunately there are not so many people understanding both worlds. And we have to bridge that gap to be better in the future. With that, I want to close my talk. And since this is a virtual event, of course it makes sense that you can contact me afterwards, and therefore we provided you with the contact information. So feel free to contact me afterwards if you have more things to discuss or have some feedbacks. Think I'm right, I think I'm wrong. So stay connected.